So in this demo, we want to write a program that converts a binary number to decimal number. For the binary number, we can either use line data type or we can just keep it in a string. Let's start by the line data type. So I'm gonna declare binary number and then I'm gonna ask the user to give it to us as an input. So we also need to declare a variable decimal number to keep the result on it. So we need to start from the rightmost digit and then keep moving to the left, and each time multiplying the digit by a number which is twice as big as the number that we used in the previous step. So we can use this variable t to generate the number that we are going to multiply each digit by. We don't know the number of iterations, so we need to use while structure. Since we are keeping the binary number in a line data type, we can just access the rightmost digit in each iteration by getting the binary number mod 10. Now if you consider a binary number, we need to multiply the rightmost digit by 1, the next one by 2, the next one by 2 to the power of 2, and 2 to the power of 3. So I can just multiply the rightmost digit by t, and I'm gonna keep it in decimal number. Now I need to update both binary number and t. In the first iteration, I convert the rightmost digit to decimal. In the next iteration, I need to update this number and remove this first part. So I can just update binary number by dividing it by 10. Also, I need to update t. In the next iteration, t should be equal to 2. So I need to multiply t by 2. I can define a variable base here to make my code more general to work with different bases. And similar to previous examples of this kind, we are gonna continue as long as binary number is greater than 0. Finally, we're gonna just print the number. And let's try the program. So let's try with something simple. And something more complicated. Now we want to keep the binary number in a string data type. So I start by including the string library and changing the data type to string. We still need decimal number to keep the result in. Since we can have access to each index of the binary number in a string data type, we can just use for structure instead of while. The order in which we evaluate each digit of the binary number doesn't matter. So when we have direct access to each digit, we just need to calculate the power correctly. So considering this example again, the length of this text is equal to 4. So the leftmost digit should be multiplied by 2 to the power of 3. So we can still have the base here. So we can access each digit using add function, and since it's a character, the first thing is to convert it to an integer. So let's try the static cast and convert it to integer. I'm just gonna queuing the result. As you can see, when we use typecasting, we just get the ASCII code of the character, not the digit itself. In order to get the corresponding integer to the digit, we just need to subtract the ASCII code of 0 from our digit. Let's try again. Now we have the right conversion. But because characters are numeric data types, we don't even need the typecast. When we subtract one character from the other one, the ASCII codes will be subtracted from each other. So if I try again, you can see that just subtracting these two characters can give us the number. So I'm gonna use this structure and I'm gonna declare a variable digit here to keep the digit in it. So in each iteration, I first need to get the digit and then I need to update the decimal number with the value that I convert in this step. So I'm gonna multiply digit by the right power of 2. What is the right power here? I start from the leftmost digit here. For the leftmost digit, the correct power is 3. For the first one is 0, 1, 2, 3. So since we have 4 digits, it's just 4 minus 1. What about the next one? The right power is 2, which is 4 minus 2. The next power is 1, which is 4 minus 3. And the rightmost one is 0, which is 4 minus 4. So in all of this, we use 4 because we have a 4-digit number. And we can just correspond these numbers with the index that we have here. So for power here, I can use binary number dot size minus I minus 1. So in the first iteration, the index is 0 and we have an extra 1 here. In the next one, the index is 1. The next one, the index is 2. And in the last one, the index is 3. So let's just include CMAS and run the code. It seems to work perfectly. Now we want to modify this code to convert a hexadecimal number to a decimal number. So in a hex number, the digits are from 0 to 9 and from A to F. We can use both lowercase and uppercase. So we cannot keep it in long anymore and we have to use a string data type. So let's start by updating the names here and then change the base to 16. So here we need to handle special cases. So we just need to check if each character is between A and F. So we're gonna check hex number at I. Let's just update these two as well. So we just need to make sure that we update digit value correctly. So we need to assign 10 to A, 11 to B, 12 to C, 13 to D, and so on. One way to do it is to get the hex number at position I and subtract A from it and then add it by 10. This way we subtract the ASCII code of A from the ASCII code of whatever character which is here. So if it's A minus A will be 0 and then we have 10. So we will assign 10 to A. And if it's B minus A would be 1 and 1 plus 10 is 11. So this seems to work correctly. We need to check the similar condition with capital letters and then update in a similar way by subtracting capital A. Finally, we will need to update digits inside this branch, and then updating decimal numbers will work in the same way for all of them. When we have the digit, the rest is just gonna be the same. So let's try it with a simple example. So for 2A, A is 10 and 2 will be multiplied by 16, which is 32. 32 plus 10 is 42. Let's try AB. So B is 11 and A is 10. 10 times 16 is 160 plus 11, which is 171.